In this video, we're going to take a look at using the remainder theorem with synthetic division. The remainder theorem states that if you divide a polynomial function p of x by x minus c, the remainder of that division will be p of c, which from section 2.2, where we talked about evaluating functions, just simply means what we would get if we took c and plugged it into the polynomial function for x. That's a y value that you get out, okay? So it turns out that if you do division by x minus c, the value of the remainder is actually the same thing you would get by plugging c back into the function. So we have two ways that we could find p of c. We can either plug c directly into the function p of x, or we can divide p of x by x minus c and take the remainder as p of c. Let's take a look at how this works with synthetic division. Okay, here's our example. Use synthetic division and the remainder theorem to find the value. Our function, p of x, is going to be 3x cubed minus 2x squared plus 6x minus 4. And the value that we're looking for here is p of negative 1. Okay, so it's a little different way to write the synthetic division problem. Instead of having a problem that says divide this polynomial by this x minus c binomial divisor, this problem gives you the polynomial function and then gives you c a little differently. Okay, here the c value is given inside that function notation. Your c is going to be negative 1. Okay, you don't have to change the sign here because it's not given to you as an x minus c. It's given to you just simply as a number. So that is your c value. Okay, so let's set this up. C is equal to negative 1. And then our coefficients and constant, it's already in descending order. I'm not missing any terms, so 3, negative 2, 6, and negative 4 are the coefficients of my dividend. All right, let's run through the process. It's the same synthetic division we did earlier in just the synthetic division video. The first thing you want to do is drop that very first coefficient. It's a 3. And then here's the process that we repeat all the way through the rest of the values. Multiply, write it right here. Negative 1 times 3 is negative 3. Then combine straight down and write that number here. Then you just repeat the process. So minus 2, or negative 2 minus 3, is going to give me a negative 5. Okay, and then negative 1 times negative 5, write it right here, is going to be a positive 5. Combine those, we get 11. 11 times negative 1 is negative 11. Combine those, we've got negative 4 minus 11, that's negative 15, and that's the end of our problem. This is your remainder right here, okay? And what the remainder theorem says is that if you divide the polynomial by x minus c, c in this case is a negative 1, then your remainder is your p of c. So p of negative 1 by that theorem is equal to negative 15. Now if you want to double check, you can. Just take negative 1 and plug it into this p of x, okay? Take your negative 1, plug it in here, here, and here, and then solve that, simplify it, and see if you come up with the same value. You should, okay? Because that's what the remainder theorem is telling you.